So where do we start? Because like SPIFFE, Spire, workload identity, and everything around this is a relatively big topic, and it can become like quite ambiguous. So like, I guess we need to start somewhere from the beginning. What is SPIFFE? SPIFFE is tracing back its roots to Google, where after the Snowden leaks, they figured out like that all of the traffic between different data centers internally were being inspected by the NSA. And so they wanted to do a real zero trust network, which was fully encrypted. And within Google, they came up with a system. I forgot like what it's called, but that's where SPIFFE is based upon. In the same way that Kubernetes is based upon Borg within Google, SPIFFE is also based on something internal. And it traces its roots back actually to Joe Beda, also one of the co-founders from Kubernetes. And he actually came up with like the first proposed SPIFFE at GlueCon in 2016. SPIFFE stands for Secure Production Identity Framework for Everyone. And as you can see in there, like this is what a SPIFFE ID look like. And it's like being able to identify your workloads in a unique way. It's the base for service meshes like Istio, Cilium, and many others. And you encode your cryptographically sign your identities in X509 certificates or JOT tokens. And as part of that cryptographically signing, you encode that SPIFFE ID as part of that one. And to showcase how this works a bit, I have like two servers where normally SPIFFE/Spire run upon, and I have a central server. So Spire is the production implementation of SPIFFE. Spire is open source. It's a both SPIFFE and Spire are graduated projects in the CNCF. So at the top, we have our Spire server, and that's kind of our main decision maker. That also holds all of the cryptographic keys that will sign all of our individual identities. And within the Spire server, we have like a node attestation. And a node attestation, we need to be able to verify when new nodes comes up that they actually are who they say they are. This can be based, for example, on metadata from our cloud providers, but that can also be, for example, information coming from, in Kubernetes clusters, the kubelets, or other external systems, like, for example, X509 certificates, SSH keys, or even join tokens, and more on that later. When a server comes up, there we also have like our Spire agent up and running. And we also have like a node attestation running on there, the equivalent node attestation running on there. What happens when a Spire agent comes up? That node attestation is going to start gathering data. Again, talking to like the metadata from the cloud provider, talking to the kubelet, or like getting information from an X509 certificate. And it's going to send that proof of the node towards the Spire server. The Spire server is going to use its own node attestation to verify that information. And if it all checks out, it's going to create a SPIFFE identity for that server and send that back for the the Spire agent. From then on, all of the communication between the Spire agent and the Spire server is encrypted with that SPIFFE ID, and mutual TLS is in place. We're duplicating this for our other server as well. And from then up, we have kind of a trust boundary where we trust that server is who it says it is, and we know what runs up on there. That doesn't mean that we trust the workloads running on that server, because once an application is going to request also its own SPIFFE ID, that Spire agent running on that server is going to verify that workload ID based on its own characteristics. That can be, for example, in Kubernetes, based on the service account. If you're running on Unix, based on the UID or the user that it's running under, based on the Docker process, for example. Like all of these kind of things can be used to verify the workload. Again, the Spire agent is going to verify that. If that's correct, it's going to be able to give it back a SPIFFE identity to that workload. We repeat this for all our other workloads. And once everything has its own SPIFFE identity encoded in an X509 certificate or a JOT token, what can happen is that application B initiates a connection to application X, and it sends over an X509 certificate public key with all of its information. Application X, thanks to its mutual trust, can verify that connection, and all of the information is encrypted. That's in a very high level, like how Spire, SPIFFE work. And then you can start doing a lot of nice things with it. And why I'm telling you all of this, and it actually traces back to this talk I've given at Cloud Native SecurityCon in Seattle earlier in the year, together with Tom Meadows, a friend of mine. And what we did during that talk is tell the story of Crush, our lovely turtle, in how it was able to talk to other workloads, other services out there, and how to actually use SPIFFE and Spire outside of like the service meshes that we have. If you're wanting to check out this talk, this QR code will guide you to it. I'll give you 1 sec to scan it if you want to. It's a story of Crash. We did a lot of ChatGPT generated images in there. Tom was really fabulous in doing that, and I'm reusing some of the images in this talk. But kind of the 4 scenarios we covered during that talk is, the first one is native. So we had like 2 microservices, both in Go, and they natively used the SPIFFE SDK to be able to set up mutual TLS between each other and do the communication with each other. The second scenario was, one is a SPIFFE native application, the other one is not. And we put an Envoy proxy in front of it that is able to get like SPIFFE certificates from Spire and then like kind of replace like that for it. And that's the way that Istio, for example, works with the Envoy sidecar proxies in the exact same way. The third one is using our SPIFFE identities issued by Spire to communicate to a SaaS provider. In that case, it was with AWS. And we are able to use that SPIFFE identity to authenticate to AWS and take certain actions. And then the last one scenario that we covered was with talking to a database with PostgreSQL. So even though PostgreSQL doesn't understand SPIFFE identities natively, we still can use our short-lived certificates that Spire gives us back for authentication with certificates. And the reason we can do that is PostgreSQL can verify identities based on the common name. And as part of like registering workloads with Spire, you can set that common name as well to like something unique per workload and use it that way. And to be able to make this work with PostgreSQL, we used an external helper called the SPIFFE helper, which is also part of the SPIFFE ecosystem, to make sure that PostgreSQL each time has like the latest certificate and it's reloaded its config so that it's always aware of that latest certificate that's out there. For the purpose of like this talk, I mainly am focusing on the native Go application and the SaaS part later down the line. So I was developing all of these microservices, and that's when I figured out like it's really hard to test. Like I was doing all of the development locally, and I didn't have like Spire running locally, but I had like Spire running on a Kubernetes cluster. So each time when I wanted to start testing this, I had to build the image, I had to push it to a registry, then update my manifest to make sure that it was running the correct version. And then like it was a lot of trial and error, and it was really hard. And my feedback loop was really long. And it felt very much like this quite common meme that everybody knows about. It's compiling, and I was waiting a lot. So when doing this, I was already thinking like, how can I improve this? But I was running into deadlines for making sure that the talk was ready. And as I like to do some conference-driven development, I kind of came up with this talk to make sure that I actually am able to do some improvements. So kind of that's when the journey started. I want to run Spire locally so I can like reduce that feedback loop. And kind of the 2 scenarios I started coming up with is running it locally in a Kubernetes cluster, like Docker for Mac can spin up the Kubernetes clusters, or you can use things like Kinds. It's really easy to replicate your production environment. Like you can just use the same Helm charts manifest. You can bring up like the exact same config of your Spire cluster, but you're still like mainly having the same problems as like when you're using an external Kubernetes clusters. You still cannot use your native tooling. You still need to load the images inside those Kubernetes clusters and update the things. So like it's still like not that great. So we of course are going to go locally, so that we can really have it native to our environment and can use all of our local dev tooling. So we're going to do this locally, and this is kind of how our architecture is going to look like. So we're going to run both the server and the agent on our laptop, and we're going to have a customer and a backend running on there as well. And for the node attestation, so to be able to verify the nodes with each other because it's really local setup, I'm going to use a one-time token ID. So like it's going to be a unique token that we're going to use. So now I need to switch. Not switching. Okay. So I have a few terminals open, and I'm going to need to do a bit of copy-paste. So I'm running on Mac, so that has a few implications. On Mac, for example, you don't have TPMs where you can do verification of the node. So what I'm going to do is I'm going to start running Spire, the Spire server. This is like the basic demo server that's running. And like when it's up, we can see like our server is healthy and it all has started up. And this is like when you run Spire locally, like these are like without modification, like the configs from the Spire repo. Now what I'm going to need to do is I'm going to need to generate a token so that my agent is going to be able to join my Spire server. So I'm generating this unique token. And then what I'm doing is I'm going to start my Spire agent with like this join token. So we can now see like that it's being attested because like the join token is known. And the join token is a one-time token. So like I use this to join with my agent to Spire server. But from then onwards, like it gets like a certificate back with its SFIT encoded on it. And it uses that SFIT then to keep authenticating itself to the Spire server. So like you cannot reuse this token, like it's a one-time token. So if you have new nodes, like you need to generate new ones. And what we can see here is with our health check, this is all now up and running and working. And our agent is healthy. The second thing we need to do is like we need to tell Spire about the workload that we're going to run on, and we need to register our workload and attach that to a specific node. And this is what I'm going to do with this entry. And as you can see here is like the parent ID is my laptop. I'm going to run a service on there, and that service needs to match my user ID as defined in here. So like it needs to, when my workload comes up and it uses my user ID, it can get this SPIFFE certificate. And that's the way that SPIFFE works. It works based on selectors. Like in Kubernetes clusters, this can be based on your Kubernetes service account. Because I'm using Unix, it's going to be based on my local ID. And you can see it's registered, and my local ID is 503. So we now have this up and running. I'm going to my SPIFFE demo. And you can see like how this works. Because I'm running as my own user, I can fetch my own certificate and get this back. And you can see here, I have like a URI, SPIFFE laptop service in there. And that's how it now works. So now I can start up my SPIFFE demo. I'm starting my backend. And I'm also going to start my customer one, which is the second one. So they have started up. And the way this kind of looks like is in here. It's a simple UI, but for us, there's a web page that goes to the customer. And when I click on this one, it's going to connect to the backend on the same host. And I'm getting a response from it because like it says laptop service and they're matching with each other. And I'm able to communicate with each other based on pure MTLS. And it does some verification because when I started up my workload, I added a -A to my service, and it's authorizing that specific service. And okay, they're running under the same user account, so they have the same SPIFFE ID, both of my applications, but there is still some basic authorization. If you really want to test authorization, what you would be able to do is run it under a different user or like these kind of things. But like that's like how the basics kind of work when I'm running Spire locally, and I can start everything up. Going back to the presentation. But that's actually not really everything, because what I'm now able to do is communicate with like applications locally. So this would be able to solve it when it's native. When I have an Envoy in front of it, because I would be able to run an Envoy locally, talk to the Spire API endpoint as well, and get all the data back. The SPIFFE helper with PostgreSQL would also work in the exact same way. But like, it wouldn't solve for my SaaS service, and in my case with AWS, because the way I talk to AWS is, for example, with OIDC, and AWS is not aware of my local OIDC endpoint, and it wouldn't work. And it would also change too much, and you would need to do a lot of reconfiguring for like each time when you bring up your Spire cluster to make that work. So the way that Cloud Access in general works is federation with cloud provider. You tell your cloud provider, this is an OIDC endpoint I have with like a whole bunch of public keys you need to trust. And if you get requests with a JOT token signed by this public key, you can trust this one. And that's why for Cloud Access, you kind of need to have a centrally managed Spire that's always there, stays there, is always up and running with like an OIDC endpoint that can work. And that also has a proof of workstation. So that kind of brings us neatly with like the second demo, where I'm running my Spire server in a Kubernetes cluster on Google Cloud. That Spire also has like an OIDC endpoint. I'll show that in a bit. It's federated with AWS. And what I'm going to do is I'm going to connect with my agent running on my local system to my central Spire server. And I'm going to bring up the same two workloads, but they're actually going to get like SPIFFE identities served by a CA that's in my central Spire server. I'm going to stop all of my workloads. I also need to make sure I delete some data, because like Spire caches some data like my keys and stuff like that. If like things gets restarted, it still has the keys, but like because I'm connecting to a different Spire server, I don't want to keep them around. So I'm removing them. And kind of to showcase, like this is my OIDC endpoint, and this is the one that is where AWS is aware of, and where it then gets like my JOT keys from. And to be able to get this, like this is a standard OIDC endpoint, and it's hosted in my Kubernetes cluster in Google Cloud. So what I'm going to do is I'm going to start my Spire agent, and note that I'm not giving it any tokens. And the reason I'm doing this is I'm switching the node attestation system, and I'm actually going to use a certificate that I'm aware of. So I told my central Spire server, trust all certificates that are being signed by a specific CA, which is my own private CA that I have created. And then what you can see here in these two, in this line, is I'm using the X509 POP, and I'm pointing it to certificates. And like many people with like enterprise laptops, like they have like some Jamf or some Intune running on that. And in a lot of cases, like through that, you get like things pushed. You would be able to get like something like that pushed to your system. So I'm starting that up. And what we see here is node attestation was successful. And you can see in this case, I'm getting like one from spire.internal.matchsgs.be. And this gets like the unique identity. So when I'm now going to Thornjack is a UI bit for Spire. It's quite simplistic UI, but like it allows me to show some things. And these are all the agents. So these are all the nodes that are in my cluster. And you can see that I have like my Kubernetes clusters in there. But here at the bottom, I have like an X509 one as well, and that's the one I have just registered. But now I still need to let my Kubernetes cluster be aware of the workload as well. Because like when I go now to my entries, Kubernetes is, Spire is already aware of all my Kubernetes workloads, but it's not aware of my workload in my, on my workstation. So when I do workload, for example, currently it's not giving anything. But what I'm going to do is give my Spire cluster this CRD. So because I have installed Spire with the Helm charts, it also has installed something called the Spire Controller Manager to automatically register all of my Kubernetes workloads. But you're also able to add some static entries to it when you have systems outside of it, like my personal laptop. And what I'm telling here is to add like this SPIFFE ID and attach it to this X509 POP, because like that's my key, my SHA-256 of my key. And it has the same selector as earlier with the Unix UID 503. So when I now do kubectl apply, it has now given this to my Kubernetes cluster. When I do a reset and I search again for workload, we can now see that this workload is registered to our Kubernetes cluster. So in the background, the Spire Controller Manager has done the same as with what I did earlier, Spire Server entry create, in the exact same way with the information I've given. So what I now can do is run things against AWS. And the way this kind of works is in my AWS config, I'm using the credential process. This is something native of AWS, where you can say in how you get your credentials. And I'm pointing this to the SPIFFE AWS assume role binary. It's something created by the people from Square for talking to AWS and getting credentials. And what this kind of does is it requests a JOT token from Spire, and then transposes that in a format that AWS understands and that can communicate that you can authorize yourself to AWS. You're telling it which role arm, for example, that you're going to impersonate. And you also need to add an audience, in this case demo, and where it can find my workload API endpoint on my local system. And so I can do this, for example. And you can see on the left, it's fetching the JOT SFIT here. This is the OIDC registration of my Spire cluster inside AWS. If I, for example, also get the role that I have referenced earlier, I'm getting AWS. And so this all goes through my JOT authentication and thus like through my Spire cluster. And you can really limit to what you can talk to based on your SPIFFE ID, and you can see this here. So the top part it's affecting allow. It needs to be coming from this federated endpoint, so it needs to come from the OIDC endpoint. But not only that, it also needs to match my sub demo, and it needs to match my SPIFFE ID. So you can see here, SPIFFE Spire internal, static MacBook Fanify workload. So like it really needs to match that. So if I'm somewhere else and I don't have like, I get like also a SPIFFE ID, but the SPIFFE ID is different, I still cannot like authenticate and authorize myself to AWS and impersonate like the other one, because like it's really locked down to your specific identity. So what I'm now going to do is I'm going to bring up my application again. This is my backend. And this is my front end, my customer one. So when I now go to here, so it's brought this up again. The SPIFFE native MTLS still works. In this case, I have like Spire internal again, but like you can see, this time matching based on the other one. But what I now can do is I can write a file to an S3 bucket. It has successfully uploaded this test file, and I can retrieve it from an S3 bucket as well. So I can talk through AWS through my SPIFFE identities. And in the background, you can see each time it has fetched this JOT SFIT, which is like always the latest, and it has done this through Spire. This works for AWS. But like this same mechanism works for everything that supports JOT authentication. So for every SaaS service that supports JOT authentication, you can kind of make this work in the exact same way. So I've done now all of this experimentation, but there is always more that can be done. And what I found out when doing all of this, it's still like gluing a lot of different components together. And we can just like improve like still the end user experience quite a lot to make it very easy to get started with Spire on your local system and then integrate that with your application, because like the whole aim of Spire is for a developer to not care about like identities or secrets or anything. Like it's to get rid of secrets in general and like have an identity on your system. But like at this moment, to get an identity on your system, you still need to do a lot of work to get that. So this can be improved. Also, a lot of the things that I've actually experimented with are really great base for providing workload identity in on-premises systems, in like VMs in data centers, where you don't necessarily have something like a cloud provider identity or a Kubernetes identity. And also where I want to experiment a bit more, but because the Mac doesn't have this, is with TPM. So like all modern servers have either virtual TPMs or TPMs, and they are like hardware modules that cryptographically verify that like this is the node. And you can use TPMs together with Spire already to verify like your node. And I want to do some experimentation with that as like the next step. But like I need to get my hands on some like servers with TPMs and not my laptop, which only has the Mac Secure Enclave. So yeah, I actually had quite a lot of fun developing this. And like I want to do more, but like, yeah, any questions around this? If you have time.
Questions?
Yeah, I'm around the whole KubeCon, and there are some Spire talks as well.
Thank you. I wanted to ask you if you have plans to make it. You show pretty much an imperative playground, basically. If you have plans to maybe, you mentioned that kind was complicated and similar to the production one. Maybe, if you could, work in the future to make it in kind so that it's easier for everyone to understand better and work better with SPIFFE and SPIFFE.
Kind is not really the problem to make it better with SPIFFE and Spire. It's more like you cannot use like your local dev tooling, like your pointers, and like when you're developing, for example, like to run debugs, like you always still like dealing with Kubernetes containers, where a lot of other talks went on debugging them. So you would be able to use them, but like it's not like really the fastest. Like you still need to push images. Like I was talking to a colleague of mine earlier in the week to kind of maybe create like something called a command line tool that makes it very easy to like spin up like the Spire server and the Spire agent on your local system, and all in one command. And he even came up with a name already, because this talk is coming from Crush, the microservice, to call it Crush CTL. So that's one of the things I'm kind of maybe thinking about, like experimenting a bit to like make it very easy to run like a local Spire server and Spire agents, and just get it like really as simple as possible.
Anybody else? There we go. The last one.
Yeah, quick question, trying to conceptualize this in a production environment. How have you seen managing the trust between app A and app X, Z and B and Y and W back to X? How does that look like in a production environment? It seems like it could get out of hand pretty quickly if you need to investigate.
You mean authorizing workloads between each other and stuff like that, or?
Maybe not authorize. Yeah, I guess authorizing to say, okay, yes, C does need to talk to D and everything else.
Yeah, so that's one of the areas that actually SPIFFE is not really opinionated about and doesn't really have a solution. So SPIFFE is really, at this moment, meant to give you a solid identity and a way to authenticate yourself to others based on common trust, based on your X509 CA kind of thing. But it's not opinionated on like how you need to do authorization. In the SPIFFE SDK, there is some ways to have some authorization, to use authorization and to like really say like, you can allow this connection or you can disallow this connection, but it's not like fully fledged like a full authorization management system. And it leaves it more like towards third parties like OPA and all of these others to kind of provide that mechanism for authorization more.
Okay, then.
Cool. Thank you. I'm still around if you have other questions. I'm here the whole day. I'm finally awake again. I got over my jet lag almost.
I think that this is the last one here, and then it continues.